Hi physical science students, wow! Welcome to the next video on ionic bonding. This time we're going to look at the formation of negative ions. So here we're talking about the non-metallic elements, the elements on the right hand side of the periodic table, and these electrons need to gain these elements need to gain electrons to achieve a noble gas configuration. And so they're aiming to have 8 electrons in the outer shell, same as the metals wanted, but in this case the non-metals are going to gain electrons to get that full outer shell. And these will form our negative ions. For example, let's look at oxygen. It's on the right hand side of the periodic table. It's group 16, has 6 electrons in its outer shell, has an electron configuration of 2 and 6. So really it would like to have 8 electrons in the outer shell. Now it's too difficult to move these 6 and get a full outer shell by just having 2 electrons in the outer shell. It's much easier for it to gain 2 electrons to become a stable anion, and because it does this and it starts off with 8 protons and it results in having 10 electrons, it has a charge imbalance of -2. And we'll look at that in a sec with the diagram. Now the electron configuration of the oxygen anion is the same as the neon atom, its nearest noble gas, and that's 2,8. And the oxygen atom is now referred to as the oxide ion, and this is what we do. We usually use the name, but we have an "ide" on the end of it, so oxygen becomes oxide. Unlike the metals, which we just called sodium ion or potassium ion, the non-metals usually have a specific name that we use. So here's our oxygen with its 2,6, and it's got 8 protons and 8 electrons, so it's neutral. If it loses 2 electrons or gains 2 electrons, it then has full outer shell, so we can see the 8 there, and this is the equation for it. Oxygen plus 2 electrons, showing the minus charge there, makes the oxygen ion or oxide, and the electron configuration goes from 2,6 to 2,8. And the way that charge works out is we've still got the 8 protons, but now we've got 10 electrons. 2 are unmatched, so there's a charge excess, sometimes we call it, of -2. Can be written as -2 or 2 minus, but always as a superscript. Now this is just a schematic of the periodic table, and you can see that the negative ions are these guys here. We would really only deal with the ions that are in your table of ions, and so we don't need to worry too much about the lower order of the periodic table. But again, the metals over here form positive ions, the non-metals over here form your negative ions. Let's have a look at a sample question. Write the symbol, charge, and name of the ions you would expect for the following elements to form. Magnesium. Okay, magnesium is found in group 2. Have a look on your information sheet on your periodic table. Has the electron configuration of 2,8,2. You need to be able to work that out, so you make sure you know how to work that out. In order for it to become stable, it needs to lose these 2 outer shell electrons because it's a metal, and the resultant ion would therefore have a charge of +2, and the symbol would be written as Mg2+, the magnesium ion. What about sulfur now? Sulfur is a non-metal. It's on the right hand side of the periodic table. It's in group 16. Its electron configuration requires 2 electrons to fill its outer shell, and therefore it has a charge excess of -2, and the symbol would be S2-, and it's called the sulfide ion. Now you should be able to do these revision questions in your textbook. You'll find them on the OneNote, but I'll also be telling you where they are in chapter 4, so you should be able to now do most of those. And the next video will actually be on bringing those positive ions and those negative ions together in what we call ionic bonding, and an understanding of all the structures and things that are related to it. So, cheerio!